If you're fascinated by nature, these images of spiral galaxies won't help you escape your fascination. These images showcase incredible detail in 19 spiral galaxies, captured face-on by the James Webb Space Telescope. The new Webb images are extraordinary. They are striking even for researchers who have studied these same galaxies for decades. Feast your eyes on the mind-blowing images of 19 spiral galaxies finally revealed. The JWST captured these stunning images as part of the FANGS program. Physics at high angular resolution in nearby galaxies. The FANGS is a long-term program aimed at understanding how stars form and how galaxies evolve over time. It is a program so costly that it was nearly canceled multiple times due to delays and cost overruns exceeding $10 billion. But now it's out there, capturing breathtaking images of the universe. But we almost didn't get it. This program has used telescopes such as hello.infinituz, the Hubble Space Telescope, and the James Webb Space Telescope for its observations. But undeniably, Webb's images are the most stunning. The JWST works this way. It can see in both near-infrared, NIR, and mid-infrared, MIR. This means it reveals different details, even far more than the powerful Hubble Space Telescope, which operates in visible light, ultraviolet light, and a small portion of infrared light. This mind-blowing image shows NGC 4254, Messier 99, a spiral galaxy located about 50 million light-years away. It is a unique galaxy because one of its spiral arms has a normal appearance, while the other is more extended and less tightly wound. But although it is not a starburst galaxy, it forms stars 3 times faster than other similar galaxies. So this rapid rate of star formation may have been triggered by an interaction with another galaxy around 280 million years ago. What we see in red corresponds to gas and dust emitting infrared light. Some images show bright diffraction spikes at the galactic center, so this could indicate the activity of a supermassive black hole. Or it could originate from an extremely high concentration of stars. Stars closer to the center of a galaxy are usually much older than those in the arms. So the farther a star is from the galactic center, the younger it tends to be. This is NGC 2835, a spiral galaxy about 35 million light-years away. This galaxy has 4 or 5 fascinating spiral arms. The blue dots you can see are very young stars that have blown away nearby gas and dust with their powerful ultraviolet light, which means they are still wrapped in their cloak of gas and dust, actively forming. And finally, if you look closely in the background, you can see some galaxies with a more intense red color. But it's not just these new images that were released. They were also released alongside Hubble's images of the same galaxies, so we were able to see a comparison between the telescopes. These images highlight how observing different wavelengths of light reveals or hides various details in galaxies. Here we can see these stunning images of the NGC 628 galaxy. The JWST image is on the top left, while the Hubble Space Telescope image is on the bottom right. Both images are magnificent, inspiring, and rich in information, but the JWST's image reveals more details. You can see large bubble-shaped gaps between the concentrations of gas and dust, so it has been concluded that this could be caused by supernovas. Since the human eye cannot see infrared light, different visible colors are assigned to various wavelengths to make the images meaningful. The bright red and orange knots in the Webb telescope image are regions of star formation, and mid-infrared light highlights the gas and dust. This is NGC 1672, a spiral galaxy about 60 million light-years away. It has a bright core and a surrounding region of starbursts, so with these photographs, astronomers can study the spiral arms in detail, providing key insights into how galaxies form, sustain, and regulate star formation. It is known that these structures tend to follow the same pattern in certain parts of galaxies. They are considered waves, and their spacing tells us a lot about how a galaxy distributes its gas and dust. In Hubble's images, star-forming regions appear as bright blue and purple clusters, or sometimes red and pink, as hot stars energize the nearby hydrogen gas, causing these color changes. Hubble and Webb are space telescopes with different but complementary missions. Hubble captures images in visible and ultraviolet light, while Webb specializes in infrared, allowing it to see farther back in time and through cosmic dust. Since it began its scientific operations, the JWST has provided astronomers with an overwhelming stream of data. But the amount of analysis that can be done with these images goes beyond what a single team could handle. These images are just a part of a larger data release that includes a catalog of approximately 100,000 star clusters. This will drive research for years and decades to come. Just as different wavelengths of light reveal or hide details in galaxies, our view of the world depends on the perspective and the tools we use to observe it. So this video reminds us of the importance of expanding our knowledge, questioning the obvious, and exploring beyond what we perceive at first glance. Thank you for making it to the end of this video. If you enjoyed it, don't forget to like and subscribe. I'd love to build a community that loves astronomy and astrophotography as much as I do. On the other hand, you can find all these and many more photographs on our website. You can buy them as a fine art print or as a framed fine art print. International shipping is completely free. It's always amazing to see a part of the universe on your wall. And you would also be supporting the creation of more videos like this. I'll leave the link in the description. See you in the next video.